Hello everyone. Today we'll be starting the revision of Poisson distribution. Now, Poisson distribution, as we started last class, we are talking about theoretical distribution. When we talk about theoretical distribution, we are basically talking about probability as a function. That means for every scenario, we'll be forming an equation. And using that equation, if I want to find the probability of 1, I'll put x equal to 1 there in that equation. If I want to find the probability of 2, I'll just put x equal to 2 in that equation, and so on and so forth. So in case of Poisson distribution also, it's a discrete distribution. We'll be finding probabilities of individual numbers. Now, here also we'll be forming a function, we'll be forming an equation, and using that equation every single time, we'll be finding out the probability of each scenario. Now, what is Poisson distribution? What is the difference of Poisson with comparison to binomial? When do we use binomial? When do we use Poisson is the foremost thing that we are going to talk about. Now, binomial, as we talked about, is used for Bernoulli trials where there are exactly two outcomes. We define them as success and failure. Now, there were four conditions. First, number of trials should be number of trials should be finite. Um, the trials are independent with replacement situations. That events have to be mutually exclusive and exhaustive, and there can only be two outcomes, success and failure. Conditions are same. In addition to that, two more conditions are required. If those two conditions are satisfied, then we say that binomial distribution can be approximated to Poisson, or in another words, Poisson distribution is an approximation of binomial under two conditions. Poisson distribution is an approximation of binomial. Poisson distribution is an approximation of binomial distribution under two conditions. First, number of trials have to be finite. Still, n is large. Now, it's a very relative word. How do we define what is large? For some people, 15 observations are large. For some, 50 is also not even large. So, it's a very relative word. So, number of trial n has to be large. That is, symbolically, n tends to infinity. And second, probability of success P is small. That is, P tends to 0. And the product n into P remains finite. Okay. In that case, we say that binomial distribution can be approximated to Poisson, or Poisson is an approximation of binomial. Now, binomial was biparametric. The two parameters were n and p, which we are talking about here. So, if I know these two conditions are there on n and p, then the product value np, which was also the mean of binomial distribution, that gives you a finite value. And that finite value becomes the only parameter of Poisson distribution. Becomes the only parameter of Poisson. So the Poisson distribution is uniparametric. Uniparametric means it has only one parameter, and the only parameter is lambda, where lambda is equal to n into p, this product, which is what? The mean of binomial distribution, basically the average value. So now please understand, sorry, please understand this very carefully. This is the foremost and most important thing here. What is lambda? If we are finding the probability of one page to have 5 errors, okay, I'm finding the probability of one page to have 5 errors, right? So lambda will be average error per page. Lambda will be average error per page. If I'm finding the probability of a box of razors to be defective, having one defective, having two defective, having zero defective, whatever, I'll find lambda for one box. Okay. Average defective razors per box will be my lambda. Okay. So lambda is basically the average value. Average for what? Average for the thing that you're finding the probability of. So if I'm finding the probability for one page, I'll take lambda for one. If you're finding probability that 10 pages have zero error, so you're finding the probability for 10 page. So you'll find lambda for 10 page. If I'm finding probability of one book, I'll find lambda for one book. That means if that book contains 100 pages, I'll find lambda for one book that is 100 pages. For 100 pages, what is the average? If my book contains 1000 page, I'll find lambda for one book that is 1000 page. 1000 pages, how many error? That will be my lambda. Lambda is the average value, mean value for the thing you are finding the probability of. Okay? Lambda is always going to be the average value, the mean value for which you are finding the probability of. तो हम अगर probability एक बंदे का बांट रहे हैं, so lambda average value will be for one person. If you are finding average, if you are finding probability for one page, you'll take lambda for one page. If you are finding probability for one book, you'll find lambda for one book. If you are finding probability for 10 minutes, you'll find lambda for 10 minutes. But if you're finding the probability, the same scenario for 1 hour is 60 minutes. So you'll find lambda for 60 minutes. So the value of lambda varies in some situations depending upon for what you're finding the probability of. So if you are finding probability, if we are finding probability for one page, you'll find lambda for one page. If you're finding for 10 pages, you'll find probability for 10 pages. Yes. Now, moving forward, the formula. Now, the formula that we had for binomial n c x p power x q power n minus x. We know that n into p is lambda. P can be written as lambda by n. Lambda is a finite value, a constant value. P can be written as lambda by n. Q is 1 minus P. Yes. Now in this, if I apply limit n tends to infinity to this scenario, if I apply limit n tends to infinity to this entire scenario, then I get the formula for Poisson distribution. So Poisson distribution, as I said, is an approximation of binomial, right? When n tends to infinity. So the formula, the same formula for binomial, when I apply limiting value, we don't need the derivation, but just the concept of it. When we apply the limiting value, then we get the formula for Poisson distribution. So the formula for Poisson distribution is e power minus lambda power x by factorial x, where x can go for any whole number. Now, this is a very important difference. In binomial, x went till only n. In Poisson, it can go up to infinity. Clear? Now, e is a fixed value. The value of e is fixed. Okay, we'll never put the value, but e has a fixed value. Okay, it will be provided in the question in general, but e is not a variable, e is a constant value. Okay, it's also known as an exponential or a transcendental quantity. Now, there is also a recurrence formula. Recurrence formula means relationship between two consecutive probabilities. Relationship between two consecutive probabilities. Formula is P of x plus 1 lambda by x plus 1 into P of x. This is the formula for recurrence relation. So if we know the probability of 0, I'll be able to find 1. If I know 1, I'll be able to find 2. If I know 2, I'll be able to find 3. That is what recurrence says. So if it is specifically mentioned that you need to find out recurrence, you need to find the probability using recurrence, then you don't have a choice. You have to use a recurrence. If it is not mentioned, that's your case, whether you want to use it or you don't. In both the cases, it's fine. Clear? How do we derive? Just divide the consecutive probabilities, you'll get the answer. Clear? Now, when it comes to properties, first, as we said, it's uniparametric. In case of binomial, mean was greater than variance. Here, mean and variance are equal, both are lambda. Standard deviation is root over variance, so root lambda. Again, here, mean and standard deviation, none of them can be negative. Third, it is never symmetrical. Why? As we studied, if p is half, only then it is symmetrical. And here we know that p is a very small number. So it cannot be half. 50% probability is a very high probability, right? So here p is always going to be smaller than half. So when p is half, we know that it is positively skewed. Mode greater than median greater than mean. And it is tilted towards right. It is tilted towards right. 4. Now, as we studied in binomial, since it is never symmetrical, mean, median, mode cannot be equal. Mean formula we know. Mode will be calculated again from lambda. It can be unimodal or bimodal, depending upon what is the value of lambda. If lambda is say 2.9 decimal, it's not an integer, then unimodal, and the mode will be the largest integer, just smaller than this. If lambda is say 5, then it will be bimodal. There will be two modes. One will be the number itself and another will be smaller than this. There will be two modes. There will be two modes. Clear? Now, let's straight the exercise. Now remember, similarly like binomial also, if I'm finding probability, find the lambda for whatever you're finding. If it is number of people, find the number of people who has zero, number of pages having zero error. Then what you will do is you'll find the probability for one page and then multiply it by number of pages. If you're finding probability, then you find lambda for that many pages. That will change. Okay, let's try this some. First question. Question. If the probability that an individual suffers a bad reaction from injection of a given serum is 0.001, that's a very small probability, determine the probability that out of 2000 individuals. Since I want to find the probability of 2000 individuals, I'll find lambda, I'll find average for 2000 people. So 1 person, 0.001, 2000 will get multiplied. So you can think in two ways. 1 person average 0.001, 2000 persons average 0.001 into 2000, which is 2. And this always gives you the hint, right? So lambda is 2. Or n, number of people 2000, p 0.001 lambda, n into p, that is 2. Any which way. Yes? Once you have got lambda, then it's always the same formula. We know p of x e power minus lambda, lambda power x by factorial x. So number 1, exactly 3. I want to find p of 3. So e power minus lambda, lambda power x by factorial x. Factorial x, 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 3. Now, e power minus 2 value will be provided in the question as it's written. 0.1353 into 8 by 6. Answer 0.18. Number 2. I want more than 2. Probability more than 2. That means I want 3, 4, up to infinity because x can go till infinity. But I cannot calculate that. So whenever they ask me in Poisson to calculate anything more than, we'll always do by 1 minus. So I have the counting started from 3. That means till 2 I don't want. P of 0, 1, 2. Taking e power minus lambda common. 1 minus e power minus 2. 1 lambda is 2. 1 minus 0.1353 into 5. Final answer 0.323. 0.323. Next. In a certain factory turning razor blades, there is a small chance 1 by 500 for any blade to be defective. That is for one blade. For one blade, average chance is 1 by 500. Now, the blades are in a packet of 10. So, in one packet, there are 10 blades. One blade has an average of 1 by 500. Using Poisson distribution, calculate number of packets. If I have to calculate number of packets, number of anything, I'll calculate first for one packet and then I'll multiply it by total number of packets. So the consignment has 1000 packets. So I'll first find probability for one packet. Yes. So now to find one packet probability, one packet has 10 blades. For one packet, number of blades 10 and probability is 1 by 500. So average value will be n into p, 0.0. Or one blade has an average chance of 1 by 500, 10 will have 10 into 1 by 500. Yes. So we will, since I want to find number of something, I'll find the probability for 1 and multiply it by total. Clear? Now, p of x we know. This will always use. What do we want? Containing no defective, one defective, two defective. So individually, first P of 0, e power minus lambda, lambda power 0 by factorial 0. E power minus 0.02, which is 0.9802. So this is the probability for one packet to have zero defective blade. One packet. Now I want in 1000 packet. So number of packets with no defective blades. For one, the answer is 0.9802. Total number of packets, 1000. So this is 1000 or 10,000? 1000. So approximately 98. Approximately 98. For P of 1, e power minus lambda, lambda power 1 by factorial 1, 0.9802 into zero point 0. That is 0.0196. So number of packets with one defective blade. For 1, we have this answer multiplied by total packets 1000. 19.6, that is approximately 20. Now, P of 2 also we want. E power minus lambda, lambda power 2 by factorial 2, 0.9802, answer 0.0002. Number of packets with two defective blades. Point 2, that is almost 0. Approximately 0 packets. Approximately 0 packets. Does anyone have any doubts till now? Third, it's a very common question. A car firm has two cars, which it hires out day by day. So their total number of cars that can be rented are two. The number of demands for cars on each day is distributed as a Poisson distribution with mean 1.5. Mean is what? Lambda. So it's given lambda 1.5. Given lambda 1.5. Calculate the probability of days on which neither car is used. Neither car is used. That is what? P of 0, right? P of 0. So we already know this formula. P of 0. So e power minus 1.5, that is 0.2231. That's our answer. Second, and the probabilities of days on which demand is refused. When will I send back someone? Suppose a person comes. I have a car, I'll give him. Another second person comes. I have the car, I'll give him. Why will I keep it with me? Third person come. Now what I will do? This is a demand. People are asking for third car. But I will say no. I have to refuse. Why? Because I have only two cars. So when will I say no to people? When more than 2% come to us, right? So probability on days on which demand is refused will only be when the people coming to demand is more than what I have. So I have two cars. So till two, I'll arrange, right? I'll give them. But if people come for more than two cars demand, then I have to say them no. So probability X more than 2 is when we will refuse the demand. That means the demand for 3 cars or 4 cars up to infinity. That means 1 minus 0, 1 and 2. Taking e power minus lambda common, 1 minus e power minus 1.5. 1 minus 0.2231. Final answer 0.1913. 0.1913. Next, suppose that X has a Poisson distribution. It's given probability X equal to 2. 2 by 3 probability X equal to 1. Probability X equal to 2 formula e power minus lambda lambda power X by factorial X. 2 by 3 times e power minus lambda lambda power 1 by factorial 1. E power minus lambda gets cancelled. Lambda cannot be 0, so one of the variable can also be cancelled. So from here, lambda will be 4 by 3. So P of x equal to 0. E power minus lambda, lambda power 0, factorial 0. So e power minus 4 by 3. Since none of the values provided, we'll leave here. Yes, we cannot calculate e on our own. That's not possible. Next, if the variance of the Poisson distribution is 2, variance is what? Lambda. Variance is lambda. Find the probability for r. So instead of x, it's using r. Okay, from the recurrence relation. So for us to apply recurrence relation, okay, we have to first find the initial probability p of 0 on our own. That we have to do. And then we can apply recurrence to calculate p of 1, p of 2, p of 3, and so on. Yes. So we know. First we'll use this formula to calculate p of 0. So 0.1353, right? And now by recurrence relation, P of r plus 1 equal lambda by r plus 1 into P of r. So first we'll put r equal to 0. P of 0 plus 1, 1. Lambda 0 plus 1, 1. P of 0. Lambda is 2. P of 0 is 0.1353. This implies P of 1 will be 0.2706. Right? Now putting again r equals to 1. 1 plus 1, 2. Putting it here. Lambda by 2. P of 1. Lambda is 2. P of 1.2706. So it remains the same, doesn't change. Putting r equals to 2. Again here. 2 plus 1, 3. Lambda by 3. P of 2. 2 by 3. P of 2 is 0.2706. Calculating this value. 0.1804. Putting r equal to 3. P of 4. Lambda by 4. P of 3. So P of 4, lambda is 2. P of 3.1804. Answer 0.0902. Putting r equal to 4. P of 5. So lambda by 5 into P of 4. Lambda is 2. P of 4.0902. 0.0361. So for us to use the recurrence, we have to initially calculate P of 0. Otherwise, it's not possible. To calculate P of 0, we will use the same initial value formula. Next. A river near a small town floods and overflows twice in every 10 years on an average. So for 10 years, the average is twice 2. So if I'm finding the probability for 10 years, lambda will still be 2. But if I'm finding it for 5 years, it will become 1. If I'm finding for 20 years, it will become 2 into 2, 4. So depending upon for what I'm finding the probability, it will automatically change. Assuming that the Poisson distribution is appropriate, what is the mean expectation? So obviously the mean expectation, mean is lambda, which is 2. Also, calculate the probability of 3 or less overflows in 10 years. So, for 10 years, we know that lambda is 2. We have to calculate what? 3 or less, x lesser than equal to 3, using this formula. This is 0, 1, 2, 3. E power minus lambda common. Putting the values e power minus 2. 0.13534 into let's keep this 4 by 3. 19 by 3. Final answer 0.855. I hope it's clear. Next, example 7. There are 500 boxes. Each box contains 1000 ballot papers. So for one box, if I'm calculating, I'll calculate for 1000 papers. The chance that a ballot paper, one paper, for one paper, the probability is 0.002. If I'm finding for 1000, I'll multiply it by 1000. That will give me one box. If I'm finding the probability for 500 box, then I'll also multiply 500. So it will matter what you're finding the probability for. Assuming Poisson distribution, find number of boxes. If I have to find number of boxes, I'll first find the probability for one box and then I'll multiply with total number of boxes. Right? So first we'll do the sum for one box. For one box. Number of papers 1000 P 0.002. Lambda average for one box will be 2. If instead of number of boxes, the question would have been find the probability, then I would have found out this into 500 again. Okay. Now, probability at most 2 defective. At most 2 is 2 or less than 2. Using this original formula. This is 0, 1 and 2. Taking e power minus lambda common. This is e power minus 2. 1, 2, 4 by 2. 0.676. Now we want number of boxes. So for number of boxes, I'll multiply this. This is for one box. Total number of boxes 500. So multiply this by 500. 338.25. So number of boxes can't be in decimal. So 338 approximately. 338 approximately. Next. On doing the proofreading of a book, on an average, 4 errors in 10 pages were detected. So average of 10 page is 4. Now, if I'm doing the finding the probability for one page, I'll find the average for one page. If I'm finding for the probability for one book, so number of pages in the book, I'll find the average for that. If I'm finding number of pages, then I'll first find lambda for one page. I'll find the probability and then I'll multiply it by the total page. So what does it want? On doing the proofreading of a book, on an average of 4 errors in 10 pages were detected. Using Poisson distribution, find, okay, question is wrong. Find number of pages with number of pages with no error and one error in 1000 pages of first printed edition of the book. So I want to find number of pages. So if I want to ever find number of pages, I'll do the sum for one page and then I'll multiply it by total. So I have to first find lambda for one page. So average of 10 page is 4. Average of one page will be 4 by 10.4. So lambda will be 0.4. Okay. Lambda will be 0.4. So we'll do the sum for one page and then we'll multiply it by 1000, that is total number of pages, to find number of page. Whenever we have to find number of something, number of boxes, you'll find first for one box and you multiply it by total number of boxes. You have to find number of pages. You'll find for one page, you'll multiply it by total number of pages. So we know we have to find number one, no error, yani P of 0. E power minus 0.04, that is 0.6703. So number of pages with zero error probability into total, that is 670.3, approximately 670 pages. Two, Roman 2, one error, P of 1, E power minus lambda, lambda power 1 factorial 1. Value 0.26812. So number of pages, this is for one book, one page with one error. Now I'm finding number of pages, so I'll multiply it by total number of pages. Number of pages with one error into 1000, approximately 268 pages. Approximately 268 pages. Approximately 268. Next. Suppose a book of 614 pages contains 43 errors. So average of 614 is 43. So if I have to find number of pages, I'll first find for one page, that will be my lambda, and I'll multiply it by total number of pages. If I have to find probability, the question is what is the probability that 10 pages, 10 pages. I have to find probability for 10 page. So lambda will also be calculated for 10 page. Yes. So it says that 614 pages have average error 43. One page will have 43 by 614. So 10 pages will be 43 by 614 into 10. Yes. That will be my lambda 0.700. So lambda is 0.7 for 10 pages because I have to find probability for 10 page. If it would have been number of pages in a book of 10, I'll first find it for one page, find the answer, and then I multiply it by 10 to find number of pages. But this is probability in 10 pages. So we have first found lambda for 10 page, and now will be free of error. So zero error. We have to find zero error using this formula. So P of 0 e power minus 0.7. The value is not provided. We'll leave it as it is. We'll leave it at it. Next. Assuming that 200 misprints are distributed randomly throughout a book containing 500 pages. So for 500, error is 200. What is the probability that a given page? Now the sum is for one page. So we'll find the average for one page and that will become my lambda. So 500 pages have average misprint 200. One page will be 200 by 500, 0.4. So lambda is 0.4. Now, number one, exactly two misprint. So using this formula, we'll find the value for two misprint. So P of 2, number 1, e power minus zero point 0.4 whole square by factorial. Its value is not provided here. E power minus 0.4 is 0.670. So 0.670 by 2. Answer 0.0536. Two or more. So two or more. That means it can be two or more than two. That means till infinity. So 1 minus 0, 1. 1 minus e power minus lambda. 1 minus 0.67 into 1.4. 1 minus 0.938. That is 0.062. 0.062. Yes. Next. First, give it a try. Read the question. Now, this will test your lambda capability every single time. Try it out first. I'll give you 2 minutes. Okay. So for a Poisson distribution model, if arrival rate of passenger at an airport is recorded 30 per hour. So if I'm doing the sum for 1 hour, that is 60 minutes, my lambda will be 30. If I'm doing for 30 minutes, it will become 15. If I'm doing it for 2 hours, it will get double and become 16. So the number of minutes for which I'm doing my sum, that will determine what my lambda is according to this. So for 60 minutes, my average is 30. Accordingly, for as many minutes as we want to do the sum, it is going to change. Yes. Number 8, expected number of arrival, that is mean, for first 10 minutes. So we have to find for only 10 minutes. So we know for 60 minutes, average arrival is 30. For 1 minute, it's going to be 30 by 60, half. We want for 10 minutes, half into 10, that is 5. So expected number will be 5. That is lambda. So for 10 minutes, my average is 5. My lambda will be 5. Yes. Number B, the probability of exactly 4 arrival, that is P of 4, in the first 10 minutes. So now I'm finding the probability for 10 minutes. So my lambda will be for 10 minutes, right? So number B, for 10 minutes, lambda is what? 5. And we want to find P of 4 using this normal formula. Yes. E power minus 5.0067, it will be provided. 0.0067, 625 by factorial 4 is 24. The answer is 0.174. Answer is 0.174. Yes. Now, the probability of 4 or fewer arrival in the first 10 minutes. Again, the sum is done for 10 minutes and we are finding the probability of 4 or less than 4, right? So C, for 10 minutes, lambda is 4. We want to calculate x 4 or less than 4. That means from 0 till 4. Taking e power minus lambda common. E power minus 4, 1, 4, 16 by 2 is 8, 64 by 6, 256 by 24. E power minus 4.0067 into 1569 by 24. That is 0.438. 0.438. Next. Okay. Important. The probability of 10 or more. That means I want to find x greater than equal to 10. Fine. Given that, now there is a condition. What is given? That already I want to find for 1 hour. So lambda would have been calculated for 1 hour. But the question did not end there. It says कि पहला 10 मिनट में 8 जन आ चुका है. तो अगर कोई चीज हो ही गया है तो उसका प्रोबेबिलिटी को चांस का तो बात ही नहीं उठता है. वी आर फाइंडिंग प्रोबेबिलिटी फॉर समथिंग दैट मे और मे नॉट हैपन. तो फर्स्ट 10 मिनट में 8 जन आ चुका है और मैं चाहती हूँ कि टोटल 1 आवर दैट इज 60 मिनट में 10 या 10 से ज्यादा जन आए. हाँ या ना? व्हाट आई वांट इज 60 मिनट में मोर देन इक्वल टू 10 है. इस 60 का पहला 10 मिनट में ऑलरेडी 8 जन आ चुका है. तो मैं भगवान के आगे हाथ जोड़ के क्या बोलूंगी कि भाई अगला 50 मिनट में क्या हो जाए, 2 या 2 से ज्यादा जन आ जाए, तो मेरा ये जो फाइनल काउंटिंग है ये कंप्लीट हो जाएगा. तो इसका तो कोई प्रोबेबिलिटी ढूंढना. प्रोबेबिलिटी क्या है? क्या होने का चांस है. ये तो हो गया है. तो जो चीज हो गया है उसका प्रोबेबिलिटी क्यों निकालेंगे हम? हमें तो अब इसका निकालना है कि भाई 50 मिनट में अब दो या दो से ज्यादा बंदा आने का प्रोबेबिलिटी क्या है. सो माई एक्चुअली सम इज व्हाट इज द प्रोबेबिलिटी ऑफ हैविंग टू और मोर अराइवल इन द 50 मिनट टाइम इंटरवल. राइट. तो हम लोगों का लैम्डा भी क्या चीज के लिए निकलेगा? 50 मिनट के लिए ही निकलेगा. सो हम लोगों का फॉर 10 मिनट, 60 मिनट बोला हुआ था, एवरेज 30, 1 मिनट 30/60 हाफ, फॉर 50 मिनट हाफ इंटू 50 दैट इज 25. सो हम लोगों का लैम्डा जो है वो होगा 25. लैम्डा विल बी 25. हमें क्या चाहिए? एक्स मोर देन इक्वल टू 2. एक्स मोर देन इक्वल टू 2 यानी 2 चलेगा, 3 चलेगा, इंफिनिटी तक कुछ भी चलेगा. हाँ या ना? इंफिनिटी तक का वैल्यू तो हम नहीं ढूंढ सकते, तो हम क्या ढूंढेंगे? 1 - 0 and 1. ई पावर माइनस लैम्डा कॉमन लिया. सो 1 - 26 ई पावर -24. इसका वैल्यू है नहीं तो यही छोड़ देंगे. दिया होता तो पुट करते. आई होप इट्स क्लियर. नेक्स्ट, सिमिलर वैरायटी. बढ़िया. फोन कॉल्स अराइव एट द रेट ऑफ 48 पर आवर. तो 1 घंटे में एवरेज अराइवल, एवरेज फोन कॉल है 48, 1 घंटे का, 60 मिनट का. तो अगर सम 60 मिनट का हो रहा है, लैम्डा 48 होगा. अगर सम 30 मिनट का है, लैम्डा 24 होगा, एंड अकॉर्डिंगली इट विल चेंज. नंबर वन, compute the probability of receiving 3 calls in a 5 minute interval of time. तो रोमन 1 में प्रोबेबिलिटी 3 तो निकालना है, लेकिन मेरा लैम्डा कितना टाइम के लिए होगा? मेरा लैम्डा 5 मिनट का निकलेगा. हाँ या ना? सो रोमन वन फॉर 1 आवर दैट इज 60 मिनट, एवरेज था 48. 1 मिनट का 48/60, 6 8 6 10 2 4 2 5 12 और 5 मिनट दैट इज 4. सो फॉर 5 मिनट हम लोगों का जो एवरेज है, लैम्डा है, वो 4 होगा. फॉर 5 मिनट द एवरेज विल बी 4. हाँ. हमें क्या निकालना है? रिसीविंग 3 कॉल्स. सो यूजिंग दिस फॉर्मूला हम लोग को निकालना है पी ऑफ 3. ई पावर माइनस लैम्डा, लैम्डा पावर 3 बाई फैक्टोरियल 3. ई पावर -4 गिवन होगा विच इज 0.018, 64/6. ये दिया हुआ रहेगा. ठीक है. ई पावर -4.018 that will be given. Calculating 0.19. ठीक है. अब नेक्स्ट सम, कैलकुलेट द प्रोबेबिलिटी ऑफ रिसीविंग एग्जैक्टली 10 कॉल्स, यानी पी ऑफ 10 निकालना है, लेकिन 15 मिनट के लिए निकालना है. तो अब हम लोगों का जो लैम्डा है वो 15 मिनट के लिए निकलेगा. राइट. सो फॉर 15 मिनट्स, नंबर 2. फॉर 5 मिनट हमने क्या निकाला? एवरेज 4. फॉर 15 मिनट्स average will be 4 into 3 12. So lambda will be 12. हमें क्या निकालना है lambda 12 के लिए? एग्जैक्टली 10, यानी p ऑफ 10. e पावर माइनस लैम्डा, लैम्डा पावर 10 बाई फैक्टोरियल 10. वैल्यू दिया हुआ नहीं है, यही छोड़, इधर ही छोड़. ऐसे भी 12 पावर 10 फैक्टोरियल 10 ये सब हम कैलकुलेट नहीं कर सकते, दैट्स इम्पॉसिबल फॉर अस. नेक्स्ट, सपोज नो कॉल्स आर करेंटली ऑन होल्ड. अभी एकदम फ्रेश स्टार्ट हो रहा है, बंदा बैठा है खाली. इफ द एजेंट टेक 5 minutes टू कंप्लीट द करेंट कॉल, मैं ही हूँ, मैं जस्ट बैठी हूँ पूरा फ्रेश, तो नथिंग ऑन होल्ड, एकदम फ्रेश स्टार्ट हो रही है. आई एम कॉल किसी से बात चल रही है 5 मिनट के लिए, what I don't want, how many do you expect to be waiting, किस में 5 मिनट में, how many do you expect in 5 minute time, 5 मिनट में आप कितना एक्सपेक्ट कर रहे हो, मतलब 5 मिनट का मीन क्या है। सो पहले फॉर 5 मिनट्स, नंबर 3 फॉर 5 मिनट, 5 मिनट का तो हम लोगों का निकाला वही था लैम्डा 4, फॉर 5 मिनट, हाँ या ना। सो 5 वी एक्सपेक्ट दैट 4 कॉलर्स विल बी वेटिंग, 4 जन कॉल करेंगे, राइट, यानी लैम्डा मेरा 4 है। चाहिए क्या, व्हाट इज द प्रोबेबिलिटी दैट नन विल बी वेटिंग, चांसेस है कि 4 होंगे, पर क्या चांसेस है कि है ही नहीं कोई, यानी वी वांट टू फाइंड इन दिस सिनेरियो पी ऑफ 0, e⁻⁴ वो दिया हुआ था 0.01, 0.01 नेक्स्ट, if no calls are currently being processed, what is the probability that the agent take 3 minutes of personal time without being interrupted by a call? 3 मिनट में 0 कॉल आएगा, इसका प्रोबेबिलिटी निकालना है, तो हम लोगों का लैम्डा जो है वो भी 3 मिनट का ही निकलेगा फिर, राइट। सो हमें क्या पता है नंबर 4 के लिए, फॉर 60 मिनट एवरेज 48 था, 1 मिनट एवरेज 48/60, 12 4 12 5 for 3 minutes, average will be 4/5 into 3, 12/5, 2.4, तो लैम्डा 2.4 हो गया। और इस सिचुएशन में एक भी जन नहीं आया, वो निकालना है, यानी पी ऑफ 0 निकालना है। इसका अगर वैल्यू देगा तो हम डाल देंगे, नहीं देगा तो नहीं डाल पाएंगे। यस, नेक्स्ट, द स्टैंडर्ड डेविएशन ऑफ अ पॉइजन वेरिएट एक्स इज √3। स्टैंडर्ड डेविएशन क्या होता है, रूट लैम्डा, ये दिया हुआ है √3, स्क्वायरिंग बोथ साइड, लैम्डा हम लोगों का 3 आ गया। प्रोबेबिलिटी 2 का निकालना है, e⁻⁻λ बाई फैक्टोरियल 2, e⁻⁻3 दिया हुआ है, आंसर 0.224, 0.2241। हमारा Poisson distribution is given 3p of 2 equal to p of 4. So thrice e⁻⁻λ lambda power 2 factorial 2, e⁻⁻λ lambda power 4 by factorial 4। e⁻⁻λ तो दोनों साइड से कैंसिल हो जाएगा, 2 लैम्डा भी कैंसिल होगा। So from here lambda square is 36, lambda नेगेटिव हो नहीं सकता, lambda is 6। अब इसको यूज करके p of x इक्वल टू 3 ढूंढना है, e⁻⁻λ lambda power 3 factorial 3, e⁻⁻6 6 क्यूब बाई ये 0.00248, 6 स्क्वायर 36, 0.0892। नेक्स्ट, मीन ऑफ अ पॉइजन डिस्ट्रीब्यूशन इज 6.25, इसका मतलब लैम्डा 6.25 है, ये मीन है हम लोगों का। वेरिएंस क्या होता है, वेरिएंस इज सेम एज लैम्डा, 6.25 ही रहेगा। स्टैंडर्ड डिविएशन क्या होता है, रूट ओवर लैम्डा, रूट ओवर 6.25, हाँ दैट इज 2.5, 2.5। If X is a Poisson variate such that P of 1 equal twice P of 2, e power minus lambda, lambda power 1 factorial 1, e power minus lambda, lambda power 2 factorial 2. एक लैम्डा भी कैंसिल हो जाएगा. लैम्डा इक्वल्स टू 1. लैम्डा इक्वल्स टू 1. ऑप्शन सी. 17. P of 1 इक्वल P of 2. MCQ है, ये देख के ही पता चल रहा है लैम्डा 2 आने वाला है. आई गई. अब P of 4 ढूंढना है. e power minus lambda, lambda power 4 factorial 4, e power minus 2, 2 power 4 factorial 4, e power minus 2, 16 by 24. That is 0.0213. Option A. If the variance is 2, variance ही lambda होता है. P of 2, e power minus lambda, lambda power 2 factorial 2, e power minus 2, 2 square by 2. So twice e power minus 2, yani 2 divided by e square. That is option A. Option A. Last sum. Very important. 6 coins are tossed 6,400 times. Then the approximate probability of getting 6 heads x time. So we did the same sum in binomial. पहले हम लोग वन टाइम का निकालेंगे. फॉर वन टाइम n 6 बार फेंका है. हमें चाहिए क्या? हेड. हेड का प्रोबेबिलिटी ये होता है हाफ. ये भी हाफ ही होगा. 6 हेड्स चाहिए यानी p ऑफ 6 चाहिए. तो 6c6 p पावर 6, तो 1/2 पावर 6 1/64 हो गया. पर हमें प्रोबेबिलिटी 6400 बार का निकालना है. सो फॉर वन टाइम हम लोगों का लैम्डा 1/64 है. फॉर 6400 टाइम्स हम लोगों का लैम्डा 6400/64 यानी 100 होगा. सो लैम्डा इज 100. हमें क्या निकालना है? एक्स टाइम यानी p ऑफ x निकालना है. e पावर माइनस लैम्डा, लैम्डा पावर x फैक्टोरियल x, e पावर माइनस 100 power x by factorial x, which is option A. Option A. Yes. I hope poison clear हुआ हो आप लोगों का. Stay tuned for more videos.